Hi, this is a sequel to my first lecture where I have introduced the concept of expectation of a simple random variable, that is a random variable which takes finite many values with probability 1. Let us try one more example to refresh our memories. Suppose x denotes the number on the upturned face of a dice when a dice is rolled. So what are the values of x? So a die has six faces. On each face there is a number from 1 to 6. But on the upturned face only one of the numbers can occur. So it can be either 1 or 2 or 3 or all the way up to any one of the six numbers. And if the die is a fair one, then each number has the same chance of occurring, that is 1 by 6. So now if I ask what is the expectation of x, where x is the number on the upturned face of the dice, I think this you can easily find out, and that would not be difficult for you to see that it will be 1 plus 2 plus 3 all the way up to 6. You add 1 to 6 divided by 6 because each probability is 1 by 6. So now let us generalize this. So suppose I tell you that x is a simple random variable and it takes n values x1, x2 all the way up to xn, n numbers, and each with same probability, that is 1 by n, equally likely. That is what we say in probability language, that x is a random variable taking all the n values equally likely. Then I ask you what would be the expectation of this random variable. Then by the same definition, it would be x1 into 1 by n plus x2 into 1 by n and all the way up to xn into 1 by n. And this is precisely equal to the mean of the n numbers, that is x1 plus x2 plus xn by n. So this is no this is a simple example that shows you that when the values of the simple random variable are equally likely, then this definition of expectation is precisely the mean of the n numbers. And this is the one of the reason that I call it that the expectation is being referred to as the mean. And in general, when the values x1, x2, xn are taken by the random variable with probability p1, p2, pn, then this sum x1 into p1 plus x2 into p2 plus all the way up to xn into pn, which we call the expectation, this is nothing but the weighted mean of the n numbers x1, x2, xn. So the way we have defined expectation of a simple random variable is nothing but the weighted mean of the values of the random variable and the weights being its probabilities. So this is why we refer to expectation as the mean. This is particularly and quite literally true in case of a simple random variable. The next point that I would raise is that I have told you that expectation of x, where x is a degenerate random variable, that is a random variable taking only one value, say c, is what, that is c into 1, that is c itself. So expectation of x in that case will be c. So now if x takes the value 0 with probability 1, then what would be the expectation? It will be naturally 0 by the same logic. Now I ask you the converse question, that suppose expectation of x is 0, then does that imply that x is the random variable that takes only value 0 with probability 1? Or loosely, can we say that expectation of x equal to 0 implies x equal to 0? I will give you an example which will answer this question. Suppose x is a random variable that takes only two values, minus 1 and plus 1, each with probability half. Then what would be the expectation? I think it's not difficult to see that in this case the mean would be 0. So, but the random variable does not even take the value 0. It takes two values, minus 1 and plus 1, both away from 0. So this points out that expectation of x is equal to 0 does not necessarily mean that the random variable even takes the value 0. And second important point is that if you see, expectation is a number, right? And but this number need not be equal to any one of the values of the simple random variable. Just to reiterate this point, expectation of x, where x takes the value minus 1 and plus 1 with probability half, was 0, but that number 0 is not even taken by the random variable. So the expectation or the average value would be a number that would certainly lie between the bounds, that is the maximum and the minimum. This we have verified, but this value need not be taken by the random variable, or this need not be a value, this need not be a value of the random variable. So this will be clearer when I explain this, explain the concept of expectation, or in the context of the law of what we call the law of large number or law of averages in statistics. So there, I would raise the following question: that suppose I toss a coin and x is the number of heads in one toss, then you know that x could be either 0 or 1. Now, if the coin is fair, then we can easily see that the expected value is half. But what does half mean? You cannot have a half head. You will either have one head or no head, that is zero head. So, what is the interpretation of the value of this mean or the expectation? That is something I will answer in my next presentation in the context of law of large number. Thank you.